In previous videos, we looked at translate, rotate, and scale, the three transformation commands that processing gives us to manipulate the coordinate system and change everything we draw. In this video, I'd like to talk a little bit about how these three transformations interact. The first thing you always want to keep in mind is that the order matters. The order in which you apply these transformations in your code, how they appear in your program, makes a huge difference. To see this, let's revisit our hillside, and I'm going to draw some bears. But I'm not even going to bother to try to fit them on the hill. I'm just going to demonstrate what happens when we change order. So this is our little program. First, I'll translate the origin. I'll move right and down by 200 and 100 pixels. Then I'll scale the coordinates. X I'll scale by -1, Y I'll scale by 0.5, and then I'll draw a bear. For the purposes of demonstration, I'm going to put the origin here in the middle of the graphics window, just so we can see things moving around. If you like, you can imagine that there was a translation preceding all of this that put it here. So, okay, this is where our coordinate system is when we start. The first thing we're going to do is translate 200 units in X and 100 units in Y. So we draw our little helper lines. Their intersection tells us where the translation is. There's the new coordinate system. I'll leave a little shadow behind of the old system just so we know where it was. And now we've completed the translation command. Now we're going to scale. So the first thing that happens is we scale the X coordinate by -1. What that means is that basically the X axis flips around. Instead of pointing to the right, it now points to the left. I'm going to scale the y-axis by 0.5. That makes it half as long as it was before. Now I'm ready to draw a bear. And when I do that, because the x-axis has been flipped around, the bear is looking to the left, and the bear is only half as tall as he usually is because we've scaled in y by 1/2. Okay, fair enough. So this is the result of translate, scale, and then drawing. For comparison, let's take a look at what happens if I scale first, then translate and draw. And I'll use exactly the same numbers. So okay, let's walk through it. First thing we do is we scale. Scaling in X by -1. Okay, that's the same thing as before. It just flips the x-axis around so it points to the left. Now we'll scale in Y by 1/2. That's fine. It gets half as long. Now we translate. But remember, we translate using the current coordinate system. So we're going to have 2 lengths of the x-axis and 1 length of the y-axis. That intersection tells us where we're going to end up. There we are. And now we draw the bear. Here are the 2 different bears that we get. 2 completely different locations. The only difference was first I translated and scaled, and then I scaled and translated. When you start mixing in rotation and then additional operations, maybe you're doing 3 or 4 or 5 of these transformations in a row, then you'll find that your bears, or whatever you're drawing, can end up wildly different in different places and orientations and sizes. So always think through the sequence to make sure you're doing your steps in the right order. Now let's talk about how some of these transforms interact. First, I'll talk about how scaling and translation are related. Here's a little graphics window with a coordinate system in the upper left, and I'm actually going to draw the pixels now. Normally, when I draw these boxes, they're meant to represent 100 pixels, but let's actually think of these as single pixels. So everything here is 1-to-1. The x-axis and the y-axis are both 1 pixel long, and each box is a pixel. So the first thing I'll do is I'll translate by 2 in X and by 1 in Y. It's going to be this little square, 2 pixels to the right, 1 pixel down. So we know what to do. Translate by 2 means give me 2 copies of the x-axis. Translate by Y says give me 1 copy of the y-axis, find their intersection, and move there. So that's the result of the translate. Now, I'm going to scale the axes, and I'm going to keep it really easy. I'm just going to scale the x-axis by 2 and leave the y-axis unchanged. So okay, let's scale the x-axis. It's now 2 pixels long. And now I want to move this whole coordinate system to the right by 2 pixels. Just like before. I won't move down, I'm just going to push right. So how do I do that? What is the proper translation command to give now to move this coordinate system 2 pixels to the right? Well, our first thought might be translate 2, 0, just like before. That would move it 2 pixels to the right, right? Well, let's find out. Remember, translate 2, 0 says move 2 copies of the x-axis to the right and 0 copies of the y-axis down. Well, the x-axis is now 2 pixels long, so 2 copies of that is 4 pixels long. So the translation command now means move by this blue arrow. If we do that, we land all the way out here. We've moved 4 pixels instead of 2. Now this is just fine if you wanted to move 4 pixels, but I said I only wanted to move 2, so I've gone twice as far as I want to go. So this is not what I'm after. I'll mark these coordinates in blue just so we can reference them, but I'm going to draw a line through that translate command because that didn't give me the result I wanted. Let's try something else. Instead of translating by 2, I'll translate by 1 in x. That says give me 1 copy of the x-axis. Well, the x-axis now is 2 pixels wide, so 1 copy of it is an arrow 2 pixels long. So, okay, we'll color that green. Let's go ahead and move the coordinates by that amount, and that lands us where we want. And I'll color those green so we can remember that they're associated with that translate command. So this is the thing to keep in mind. When you've scaled your coordinate system and you then translate, the translation is always with respect to the scaled system. So if your axes have gotten bigger or smaller, you need to adjust the amount by which you're translating. If this seems a little theoretical and academic, don't worry about it. The first time you try to do this and things come out in the wrong place, all you need to do is to sit down with a piece of pencil and paper and draw where you want your thing to land. And then take a look and see where it's landing. And you will remember this video and you'll say, aha, my axes are too big or too small because I've scaled them, and you'll fix your translation. It'll be clear as day. The interaction between scaling and rotation is even more interesting, and it's even kind of surprising. Here's our graphics window, and I'm going to scale up the 2 axes by different amounts. Now this is absolutely key to the effect we're going to see. If you scale both axes by the same amount, that's called uniform scaling, then you won't see the effect we're going to see. So I'm going to scale the 2 axes by different amounts. I'll scale the x-axis, shown in red, by 3. And the y-axis I'll scale by 1, which won't change it at all. So okay, let's scale up the x-axis by 3. To cement the fact that the x-axis is 3 times wider than it used to be, I'm going to remove the grid lines along the x-axis. So now we have these cells that are 3 times wider than they are high. Each one of these rectangles represents the box we get constructed by the x and y axes. Now I'm going to add rotation. So I'll rotate by, say, 20 degrees. I'll hand that off to radians to turn it to radians, and I'll call rotate. And now watch what happens. Okay, this is really weird. This is wild. What has happened is that our rectangles have turned into parallelograms. This is exactly what is supposed to happen. This is just what the math tells us happens when you scale non-uniformly and then rotate. The rectangles turn to parallelograms, and most importantly, the x and y axes are no longer perpendicular to each other. They no longer meet at a right angle. They meet at some other angle. One way to think about this is that the rectangles look like they've been slid over into these parallelograms. This operation is called skew or shear. These are 2 names for the very same phenomenon, and it's the phenomenon illustrated here where after scaling non-uniformly and rotating, the axes are no longer at a right angle. Let's see what happens if we draw something in this coordinate system. Let's draw a rectangle, and we'll see what we get. To figure out where the rectangle is, let's first ask, where's the upper left corner? That's given by the first 2 values in the rectangle called 200 and 0. Remember that our x and y axes, as being drawn here with the red and green arrows, are all being blown up by 100 so that we can see them. So to move 200 units in x means 2 copies of the red arrow. We're moving 0 in y, so we have 0 copies of the green arrow. So starting at the origin, we move 2 copies of the red arrow, 0 copies of the green arrow, and the upper left corner is right here. Now the rectangle is going to be 100 by 100. Remember that each of our original boxes was 100 by 100, and then I scaled the x-axis by 3 and took out the intermediate lines. That means that each of these parallelograms is still 100 by 100 as far as processing is concerned. So if I draw a rectangle using this rectangle call, we get this. Wow. So our rectangles turn into parallelograms. Let's try the same thing with an ellipse. Where's the upper left corner? It's at 200, 100. That's 2 copies of the big red arrow, 1 copy of the big green arrow. That puts the upper left corner of the ellipse right here. And the ellipse itself is 100 by 100, meaning it fills one of these parallelograms, and there's the ellipse. So this is pretty wild stuff. You get skew or shear when you scale non-uniformly and then follow it up with a rotation. If you always scale uniformly, you will never see shear. This is really a very useful modeling tool in some situations. Sometimes you want exactly this kind of effect, and when you do, there's the recipe. Scale non-uniformly and rotate. You might have to play with the numbers a little bit to get exactly the effect you want, but you'll always be able to find it. Let's take a look at skew in action. Here I've got 3 animals, and I'll start skewing them in X. And you can see it causes them to just sort of get pushed over. They're leaning over to the side. They're not rotating. They're being kind of slid over. And again, that's what we call skew or shear. Let's put them back into the center, and now I'll skew them in Y. And again, they look like they're being slid. And tell you what, let's put it back into the middle, and I will do some X and Y shearing, and we can get these kinds of interesting effects. So if this is something you want to do, you certainly can, by all means. Do a non-uniform scale and follow it with a rotation. If you don't want this kind of an effect, and you never want to see this ever, then always make sure that you're scaling uniformly.